This video is going to cover lesson 6.5 over kites. Make sure you have your practice worksheet and your hierarchy out so we can fill out some things on here. Okay, so before we start talking about a kite, I just want to point out where it falls in our hierarchy. Okay, notice that the only thing above it is a quadrilateral. Okay, so it's more specific than a quadrilateral, but less specific than everything below it. Okay, so if we're taking a look at what's marked on your hierarchy, you'll see tick marks on the top two and tick marks on the bottom two sides. Okay, so the definition for a kite is going to be two pairs of consecutive side. Notice that the ones that are congruent to each other are next to each other, that are congruent. And I'm going to go ahead and mark that on my picture here. Of course, we have to talk about the diagonals as well. So go ahead and pause the video and draw on your diagonals. Okay, well, the ones we've talked about so far, diagonals could be one or more of three things. They could be bisectors, they could be congruent, or they could intersect at a right angle being perpendicular. Okay, so we're going to start with looking at bisectors. Bisecting means either half of the diagonal, okay, so are congruent. So if I look at where these two diagonals intersect, this side is equal to this side. Okay, so this diagonal cuts this one, or bisects it in half. However, if we take a look at the other diagonal, it is not split in half. Okay, so they do not bisect each other, only one is bisected. Okay, and while we're talking about that one, we might as well go ahead and mark it. If this diagonal is cut in half, we know that either side should be the same length. Okay, but we've gotten rid of can't be bisectors. Congruent, you can obviously tell that the total length of the diagonals are different, so they can't be congruent. The only thing left is perpendicular, and in fact, the diagonals of a kite are perpendicular to each other. Okay, well, we've got a property that goes along with kites, and that has to do with the angles. Okay, if we take a look at this picture, not both pair of opposite angles are congruent. If you notice, this one here is a little bit smaller than this one. Okay, but the top and the bottom are congruent. Now, this is called a kite. So I'm actually going to draw a little string on my kite to talk about the names of these angles. Okay, this I would consider the end of my kite, where I can draw the string. Okay, so opposite is also an end. And then the other two angles, the ones that are congruent to each other, are the non-end angles. And that's my property. Okay, the non-end angles are congruent. Now, another way to think of end or not ends, okay, the ends are where the two congruent sides meet. Okay, notice this vertex is formed by the congruent sides. Same way with this one, the two congruent sides form the end. Okay, if you don't want to draw the string on your kite. Okay, so we're going to use these properties to answer some questions about quadrilaterals in general. Okay, we've covered all of the different types of quadrilaterals now, so we can be as specific as possible. Okay, the first one, we've got sides marked, and if you notice, opposite sides are congruent. That, of course, is a parallelogram. Because our opposite sides, both sets, are congruent. The next one, we've got two things marked. The first is one pair of parallel sides, and the second thing is I've got one pair of opposite sides that are congruent. Well, the one pair of parallel sides tell me it's trapezoid, and then these opposite sides are called legs for an isosceles trapezoid. Okay, so we want to give those two reasons, because there's two things that made it an isosceles trapezoid. The one pair of parallel sides made it a trapezoid, and the congruent legs made it isosceles. All right, for the next one, we've only got angles marked, so we want to see if any are congruent or supplementary. Those are what our properties have to deal with. Okay, if you notice, the top two and the bottom two are congruent to each other. As for supplementary, the side two pairs are, the top two pairs aren't. Okay, so not all of the sets are supplementary, but two of them are. Okay, well that part right here, the two side angles that are supplementary, make it a trapezoid. And the fact that the bottom and the top, if you remember, our base angles are congruent, that makes it isosceles. Okay, so this is an isosceles trapezoid. Because, again, trapezoid, we've got, I said you could call this two pairs of consecutive angles that are supplementary. That's the same thing as saying you've got a pair of parallel sides, because the angles between them are supplementary. And it's isosceles because the base angles are congruent. All right, next one. All sides are marked, and they're marked with the same number. That is a rhombus, because you got 4 congruent sides. What I'd like you to do is pause the video and see if you can come up with the next 4 types of quadrilaterals. On number 5, you should have gotten quadrilateral, because while we have one pair of opposite sides that are congruent, that's not enough to call it a parallelogram. It can't be anything else. We just got 4 sides. Now, on number 6, only thing that was marked was perpendicular diagonals. Okay, we have no other information, so simply perpendicular diagonals and not perpendicular and anything else, that's a kite. Okay, well, from the last problem, we know that this is a kite because of that right angle, and what we need to know is, do these tick marks allow us to be more specific than a kite? Okay, well, we know about kites, we have consecutive sides that are congruent. Okay, 2 different pairs. So if I'm looking at this one, I know that either this one next to it or the other one has to be congruent to it. Now, since the opposite has a tick mark too, we can say really those consecutive sides are the same, and so are these ones. Which, if you notice, now we have 4 sides that are congruent. So this is more specific than a kite. It's actually a rhombus. Okay, so we're going to give the reason we knew it was a kite, so we could mark that extra information, was because of the perpendicular diagonals. And then it was more specific than that because of the 4 congruent sides. Alright, diagonals are marked on this one. We need to decide what's happening. Since you have the same tick mark on either side, that means they are bisectors. And since the total length has the same number of tick marks, that means they're also congruent. Okay, so we're looking for congruent bisector diagonals, and that is a rectangle. Okay, pause the video and take a stab at the next 4. Number 9 is kind of tricky because it almost to me looks like a square. Okay, but let's talk about each piece separately to start out with. This right angle on the diagonals tells me it's a kite. And I know kites have consecutive sides that are congruent. Okay, well, I have that marked here. Now, this right angle is marked, but what we need to decide is that enough information to decide whether all of the other ones would have to be. Okay, and I'm going to tell you no, because while this looks like a square, we don't have any information on the inside marked about sides. Okay, so we're not sure whether really something like this is going on with the other side. Obviously, it's not that dramatic or it'd be drawn that way. Okay, but that could have been extended out farther. Okay, because of that, because not enough information is marked to label any other right angles, this we just have to call a kite because of the perpendicular diagonals. Okay, the next one, 3 right angles, is enough to mark 4 though, so we can call this a rectangle because of exactly that, 4 right angles. The next one, angles are marked, opposite ones are congruent. That was a parallelogram. Opposite angles congruent. Now, with the next one, okay, we've got 100 degrees, 70 degrees, 102 degrees. So far, no angles are congruent, so the other thing that we checked are any supplementary. Okay, well, I can see 170 are not, okay, and then I could see 70 and 102 are not. Now, to be sure that none of them will be supplementary, which I can tell from right now that they aren't, go ahead and solve for the missing angle there. Okay, you should get 88 degrees. And based on that, that pair and that pair are not supplementary either. So I've got no supplementary angles, no congruent angles, and I've just got one pair of consecutive sides that are congruent. That is not enough to tell me anything about these side lengths, so we're just going to call this a plain old quadrilateral because it's got 4 sides. Okay, the next one though, while none of them are congruent, there are some that were supplementary. Okay, the left 2 added up to 180, and so did the right 2. Okay, well that makes the top and the bottom parallel to each other, so this is a trapezoid. Okay, and you can either mark that and say one pair of parallel sides, or you can say I've got 2 pair of consecutive angles that are supplementary. Okay, they have to be the ones opposite each other, okay, but it's hard to say consecutive and opposite. Okay, well, 14 is similar. If this adds up to 180 and the whole sum of the interior angles is 360, well, there's only 180 left over. So again, this is a trapezoid for the same reason as before. So I'm going to use the second way that I'll let you write this. As long as you mark that with arrows, you can say instead one pair of parallel sides. Alright, the next one, I've got 120 and 60. 120, if you solve for the missing angle here, you will get 60 as well. So opposite angles are congruent. That makes it a parallelogram. Okay, but even more than that, when you have a parallelogram, we know that opposite sides are also congruent. So if I got a tick mark on top, I'll have one on the bottom as well. Same thing goes for the left. If I have one there, got to have one on the right. So now I know this is a rhombus. for two reasons. The first was the opposite angles were congruent. That made it parallelogram so that I could mark the other information to know that I've got four congruent sides. Okay, you have to have both reasons there. 16, diagonals are marked. Okay, so we're looking for three possible things: bisectors, congruent, or perpendicular. Okay, well, perpendicular can't be because I don't see a right angle marked, and I don't care how close to a right angle it looks. Okay, if it's not marked, we don't know. So I'm going to check bisectors next. The halves where they intersect on either side are not equal, so that means they're not cut in half, they're not bisected, so not that. However, our entire length adds up to 6 on each diagonal, so they are congruent to each other. Okay? If I just had congruent diagonals and nothing else, that's an isosceles trapezoid. And this is one of the instances where you can use only one reason because you only had one reason given: congruent diagonals. Okay, 17 is an isosceles trapezoid. 18 is a parallelogram. You should have no problem solving for the variables on those ones. Okay, we're going to take a look at the one that we learned today, a kite, number 19. Okay, the first thing we're looking for is x, and x is this angle here. Okay, well, if I focus on this triangle that is formed by my diagonals, I can see that I've got a 20-degree angle here. So I just have to decide what this angle is. Now, I knew it was a kite because my two congruent sides are marked there, and my other two congruent consecutive sides were marked over there. If it's a kite, I know that the diagonals are perpendicular to each other, so that has to be a right angle. Based on that information, I know that those three angles, x, 90, and 20, have to add up to 180 since it's a triangle. So I've got x plus 110 equals 180. If I subtract that 110 over, I get x equals 70 degrees. The next one I need to look at is y, and that's a side. But if you notice, it's a side of that same triangle that I have highlighted. Okay, so I'm just going to sketch it out here so maybe we can see it better. I've got this bottom length of 30, this side length of 12, and my hypotenuse across from the right angle is y. Okay, so I'm going to use the Pythagorean theorem, a squared plus b squared equals c squared, where my c is my hypotenuse, my y, and then my a and my b are 12 and 30 in whatever order you want. Okay, so we just have to simplify here. Okay, 12 squared is 144. Now, 30 squared you can actually think of 3 times 10. If you do that, square 3, and that's 9. 10 squared is 100. So if I square 30, I should get to 900. So combining like terms, I get 1,044. And then I'll take the square root of both sides. Okay, we're looking for the biggest perfect square that goes into 1,044. Okay, so pause the video and search through your perfect squares. Okay, it will not be larger than that 225 that you know. Okay, the biggest one was 36, and it went in 29 times. Then, of course, the square root of 36 is 6, and then that's multiplied by the square root of 29 because we can't break that down. Very similarly, we will find z Okay, it's another right triangle on the other half of our kite here. The side length here still stays 12. Now our bottom is 20. Okay, so we'll set up the Pythagorean theorem again. I've got 12 squared plus 20 squared equals z squared. Okay, again, I've got 12 squared, so 144. Okay, 20 squared is 2 squared times 100. Okay, so 2 squared is 4. That should be 400. And then I just have to add those together to get z squared. Okay, so we should get 544 there equals z squared. And again, we're taking the square root of that. You've got to look for the biggest perfect square that goes into 544. Pause the video and go find that. Okay, the biggest perfect square was 16, and it went into 34 times. Square root of 16 is 4. So z is going to be 4 times the square root of 34. Okay, you can get decimal numbers for those as well. Okay, now we're going to look at some ideal problems. This first one, we've got, in a parallelogram, the two obtuse angles are twice the measure of the acute angles x. What are the measures of the angles within the parallelogram? Okay, so my question is exactly written. So what are the measures of the angles Part D, it's best to draw a picture. Okay, so we are looking at a parallelogram. Okay, so use your geometer to trace a parallelogram so it looks better than mine. And then we know something about a parallelogram. Okay, in our wording up here it says two obtuse angles and acute angles. Right? If you remember, opposite angles in a parallelogram are congruent to each other. And we're told the acute angles, or the smaller angles, are x. So put an x in for each of those smaller angles. And then we're told the two obtuse angles, so the other ones, are twice the measure of that. Twice just means 2 times. So it's 2 times that x value, or 2x. So if I need to solve for x so that I can get all my angles, I just have to figure out how to set up an equation, part E. Hopefully by now you know that the interior angles in a quadrilateral add up to 360. So I'm going to say x plus 2x plus 2x have to equal 360, because those are my 4 angles. A is act on it, or solve for the x. We've got 1, 2, 3, 4, 5, 6x total equals 30, or 360. And then we'll divide by 6 on both sides. 36 divided by 6 is 6. Just drag down that 0. Okay, so x is 60 degrees. Okay, so I know that these two angles are 60. But I still have to go find the other two. Okay, so I'm taking 2 times 60 and then 2 times 60 again. And that, of course, gives you 120 degrees. So if I want to answer my question in a complete sentence, I will say the measures of the angles are 60 degrees and 120 degrees. Okay, we're going to do one more of those. I'm framing up a square patio for my backyard, and the side lengths are 10. Okay, well, if you remember, square has all side lengths that are the same, so all the sides are 10. What we want to know is, what is the length of the diagonal going to be? Okay, so part I, what is the length of the diagonal? D, go ahead and draw yourself a picture. You've got a square on your geometer. Okay, and I also want you to take time to mark what you know about a square. Okay, squares we already talked about having all congruent sides, but it also has all congruent angles. Okay, they're all right angles. So mark that as well. It's going to help us find the length of the diagonal. Okay, well we know that squares have congruent diagonals, so we just have to draw one of them in. And the other one's going to be the same exact length. Okay, well we also know not only are these side lengths congruent, but they're 10 feet. Okay, so I'm going to mark that one 10 foot, and same thing with the other one. Now, I only marked 2 of the sides. We know they're all the same, but I only marked 2 because now I can focus on this right triangle because I'm trying to solve for this missing hypotenuse length x. Okay, since it is a right triangle, we're going to use the Pythagorean theorem again to solve for my missing side. So I will have 10 squared plus 10 squared equals x squared. If I act on that, I've got 100 plus 100 equals x squared. Go ahead and combine your like terms there. 200 equals x squared. Again, we're looking for the biggest perfect square that goes into 200. Now, for this one, you don't have to work hard because the biggest perfect square is written in the step above. Okay, 100 goes in 2 times. Okay, this is the case where, if you remember, we've got that pattern. It's an isosceles right triangle, and for any isosceles right triangle of side length x, the hypotenuse will always be x times the square root of 2 because that's your x squared. And your x squared always goes in 2 times or appears twice when setting up this problem. So we will say that the length of the diagonal exactly is 10 radical 2. Let's see. It doesn't ask for exact or approximate, so if you want, you can give it both. We've got the length of the diagonal is 10 square root of 2, okay, or approximately 14.1 feet. Okay, if you have any questions, be sure to come by and ask.